So just before we get into surface area and volume, it's good to note the names of all of these things. And so what we're going to be doing first is just naming them. And there's a difference between when a shape comes to a point versus when it just rises normally. If something rises to a point, I don't know if I can write this anywhere. So if it rises to a point, we're going to call that a pyramid. Otherwise, if it just rises up normal, we're going to call that a prism. And so let's take a look at kind of what I mean. First of all, I'll acknowledge that these drawings are pretty bad. So I didn't do them, but whatever. This one is called a sphere. So that's just normal. Now let's take a look here. This is the base. I realize this is up top, but this is the base. Just like over here, this is the base. Either one of these actually could be labeled the base. But here we've got a circular base, and then it rises, or in this case lowers, but it rises to a point. So if you're going to name this, you always start with the name of the base. In this case, the name of the base, the shape of the base is a circle. So we call it circular. So it's got a circular base, or it's a circular, and then because it comes to a point, we say pyramid. Circular pyramid. I don't even know how to spell pyramid, apparently. Pyramid. And again, it's a circular base, and it comes to a point. Compare that to the second one. It is also a circular base, but it does not go to a point. It continues on, and those are called prisms. P-R-I-S-M. So you always start with the shape of the base, and both of these, the bases are circles, so you say circular. But this one on the left comes to a pyramid, because it comes to a point, and this one is the one on the right, it's just a prism. So let's keep looking down here. Well, let's see if we can figure this out here. Okay, I can actually move this without making things weird. The base on this next one, any one of them could be the base, but we kind of see this at the bottom here as the base. And that base is a rectangle. So we say, hey, it's a rectangle. And we're going to call that a rectangular. Does it come to a point? Nope. So we call that a rectangular prism. I've just realized here that I've kind of written these in the wrong spot. So let me just write this here. Rectangular prism. Because the base is a rectangle and it just continues on to whatever shape that it is. This thing, I think the intention was to make this base right here. What the intention was to make it a square. So we're going to call this just a square prism. Otherwise known as a cube. And moving on here. This is a very odd one. Most of us want to call this the bottom, call that the base, but it doesn't come up to a point. You think, well, it kind of does. Well, if I said this came up to a point, I would get something that all the sides would go up to one single point. And here, the base is coming up to not a point, but a line. So it's very strange, but this is actually right here, the base. It's just been moved over. So, I mean, really what this thing looks like is something like this. So this is the base, and it just kind of goes up like that. But in this case, it's kind of been pushed over. So that's the base, and it all goes up normally. So this has a triangle, so triangular. It's a triangular base, and it does not come to a point, so we just call it a prism. So you're looking for it to go up. A prism is one that goes up to its exact same shape. So it's got a base, and it goes up to the exact same shape that's up there. So it's a triangle-based or a triangular-based prism. Here, the base, again, it has to go back into, if this was the bottom, it goes up to a line, like it doesn't match up. But if you notice on the side, if this was the base, it goes to that on the other side. So this is, whatever shape this is, it's been pushed over. Now this has 5 sides, so it's a pentagon based prism. Prism because it goes up to the exact same shape on the other side. If it came to a point, you would see that all of these things would kind of go up to one single point, and we'd call that a pentagon-based pyramid, but it doesn't. This, again, we can have this as our base. And it goes up to the exact same shape on the other side. It is 1, 2, 3, 4, 5, 6. That is a hexagon based, and it doesn't come to a point, it goes to the exact same shape. So we call that a hexagon based prism. Over here, I don't know how many sides there are, but this is my base, and it goes to that exact same shape on the other side. And 1, 2, 3, 4, 5, 6, 7, 8. 8. So an octagon. Octagon based. And it is a prism. Is there any more here? Okay. So we've got a base here. This is our base. And our base that is a rectangle. So we can say a rectangle base, but we can also say rectangular. So it's a rectangular and comes to a point, so we're going to call that a pyramid. Rectangular pyramid or rectangle-based pyramid. This, I think the intention was for this base here to be a square. So we would say a square-based. And it comes to a point, so we would call that a pyramid. A square-based pyramid. Anything else? Okay. And we have a base here. And it comes to a point. Now the base is a triangle, so it's a triangle base or triangular. And it comes to a point, so we say a triangular pyramid. Oh, this is a 5-sided, so that's going to be a pentagon. Based, and it comes to a point, so we'll say a pyramid. And this is our base down here. And again, we've got a base down here. I don't know how many sides this is. 1, 2, 3, 4, 6. So hexagon based. And it comes to a point, so we'll write that as a pyramid. And then I'm assuming this is going to be that 8-sided thing. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8. So this is a octagon. Based, and it comes to a point, so we say a pyramid. So again, our base is down here. Is there any more? What the? Let's wait for a minute. And let's start over here. Now these aren't as important to us in terms of calculating surface area and volume, but this is 8 sides, octa. This is called an octahedron, or octahedron. It's hard to pronounce it. Octahedron. And this is known as a I think it's a dodecahedron. I'm going to just double check. Dodecahedron. So yeah, that's right. I'm just going to spell that. Dodecahedron. And the last one is icosahedron. And we won't be calculating surface area and volume unless it was like maybe an extension question or a challenge question or something like that. Let's just take a look here to make sure that I haven't missed anything. Now, just to summarize, the top row here has all a bunch of circle stuff. It's all of our circular things. I don't know how to write that, but I'll try here. Circular. So that whole row is circular things. And then the next 2 rows are all of our prisms, just depending on what our bases are. So these 2 rows are all of our prisms. So triangular, square, rectangle, pentagon, hexagon, octagon. And then we have our next 2 rows, and these are all of our pyramids. Exact same bases. I think exactly the same. Triangular, square, rectangle, pentagon, hexagon, octagon, all of our bases. And then of course the last row is just kind of those little more special ones. So you got all of our prisms, we got all of our pyramids, and then we got those 3 at the bottom, which are all of our circular things, like a sphere, a cone, which we call a circular pyramid, and then our prism, circular prism, which we call a cylinder. So we might actually want to add those in here. For the circular pyramid, we also call that a cone. And the circular prism one, we call that a cylinder.